Hello and welcome back. So we are on example 13. This is on page 5 of our compound interest packet, and we're solving for time. And if you haven't watched examples 11 and 12, you want to go back and watch those because those came before that example 13. So if you're on to example 13, you have found the right place. And I'm going to start by letting F, P, R, N, and T. We're going to set those up and have those ready to go on the left-hand side. And like usual, we're going to notice that the words in here say, how long will it take? Right? So in these T problems, you're always asked, how long is it going to take? And in example 12, and I won't turn back, but example 11, we were given the final value and we were given the starting value. And we got quarterly, we got the rate. Down here with 13, you're going to notice that the prompt is a little skimpier. It says at 3% annual interest compounded monthly, so we can fill in 0.03 as well as the end value of 12 because it's monthly compounding. It wants to know how long will it take to double your money? So you might be saying, this is kind of strange because in the last two problems, they gave me a dollar amount, like 1,000, 6,000, goes from 1,000 all the way up to 6 or whatever it was. In this one, they don't give you a specific dollar value. So you might be thinking, what do I do? And I don't get to say this often in math class, but you get to make it up. Sounds kind of weird, right? Like, whoa, really? That's all I get? Really, you can make it up. So when they give you double your money, you want to think, okay, well, if I started with 100, then 200 would be doubling. Sorry, a little arrow there, right? 100 would double as 200. So I'm just going to use 200 and 100. I could use 1,000, 2,000. I could use 1 million, 2 million. But in a second, you're going to see why it doesn't matter. So that is your table for example 13. And as always, we're going to start with our compound interest formula. It's good to see the whole thing out there in its glory. Okay, so 200 is our F value in this problem. 100 is the P value. We get 0.03 as the rate, and then 12 is our N value. This is NT, so this is going to be 12T. So time is what we're solving for. So 2 steps, the cleanup and the divide by P. So first off, let's divide by the 100. And this is when you're going to see that it didn't matter what we chose as long as they were values that were double. So 200 divided by 100, what's that going to turn into? 200 divided by 100. You guessed it, 2. So as long as you divided, right, as long as you divided F by P and you get 2, you're all set. So that's why I say you could have chosen like 45 and 90. You could have been very obscure. But as soon as you divide the final value by the initial, it needs to have a ratio of 2. So by doing that, we got rid of the hundreds. And we need to figure out what's on the inside there. So 0.03 divided by 12 and enter. You get 0.0025, and then we would add 1 to it, and that is the base of our expression. So we've got 1.0025 raised to the 12t power. So once again, we are set up and ready for our logarithm, right? We can maneuver this so that we change the base to be the base of a logarithm. The answer will come next, and the exponent is on the other side of the equal sign. So we've got log base 1.0025, and then the answer is 2. So what this is essentially asking is, what power is needed to bring 1.0025? What do I need to raise that to get to 2? So You could always kind of do a little guess and check game on your calculator here to start testing it out. So, okay, let me raise that to the 20th power. So 20th power only got me to 1.05, and I'm trying to get to 2. So I need more. We need more juice there. So 1.0025. Let's raise it to the 100th power. Are we at 2 yet? No. We're getting closer, 1.28, but not there yet. So that's why we can't really guess and check with this. We just have to do the math out. So we're going to use the online graphing calculator that I showed you to calculate this log. And let's go over here. This kid with these cool shirts, huh? 1.0025. And the answer was 2. So we'll calculate. Whoa, holy schmoly, as Miss Bannock would say. 277.6053, blah, blah, blah. So I'm going to write that in on my work here. 277.60530159. Now, you may be thinking, let me get you back here so you can see. You may be thinking, that's a lot of years to double your money. 277? I don't think any of us will be here if that's how long it took to double your money. But wait, there's more. This was equal to 12t. You see that? So because it was multiplied by 12, we've got to divide to get the actual answer there, my friends. So 277.60530,159. I know I'm crazy. I love the precision though. And divided by 12, there's 23 years and change. So we got t equals 23.13377513. And we're going to round that to 3 decimal places. And that 7 is going to make that 3 go up. So we are at 23.134 years. So if you had to answer that question, how long will it take to double your money? It will take 23 and some months of time. Okay, 23 years and a little bit of change. So definitely not an easy skill, right? But with practice, finding time is going to definitely be a success for you if we practice, and just ask questions next time we're in class and we'll get you there. Okay. I'm noticing example 14 is really small. It says, if you were asked to find the amount of time necessary to quadruple an investment, what are some values you could use for F&P? I'm just going to go back to my $100 investment. Quadruple means times 4, so you could use $400 there. Okay, so that's how you want to fill in example 14. You don't have to choose my values. You could choose whatever you want. You could choose something as easy as $2 and $8. Anything will be fine. So as long as when you divide F and P, you're going to make sure that you get a 4 as an answer. So F divided by P must equal 4 in order to quadruple. All right, that is plenty of time. I gotta get headed home and cook some dinner. So I hope you enjoyed taking these notes with the video, because I think it's nice for you to be able to back it up and rewind and hear what I said a second time, or maybe a third. So have a great day, and I will see you soon.